Hello everyone, you are welcome to today's lesson. In today's lesson, we are going to look at conditional probability. If you remember when we were dealing with dependent and independent events, these two special events, the multiplication rules, you realize that I made use of a certain notation in probability where I use a line. So you saw this. We said, especially in the dependent situation, I gave you this. If you have P, A, and B, or A intersection B, this will always be equal to P of A times P of B, given that A has already occurred. And this is what we refer to as the conditional probability. Given that, so it's based on a certain condition. So anytime you are dealing with a conditional probability, then it means the chances of B occurring will be affected by the A that has occurred. As simple as that. So quickly, let me read what we have here. Conditional probability refers to the chances that some outcome occurs given that another event has already occurred. I hope it is well understood. The statement is clear. It is often stated as the probability of B given A, and it's written as, so this is the notation, PB given A. And take note, it is not like this. I would have addressed that in the core math assignment. It is not PA over B or PA, then you do this B. No, it's not over. It is just a bar. Well, sorry, yes. So it's this. The worst you can do is to slant it. But the A and B should all be on the same line. Take notes. So where the probability of B depends on that of A happening. And it is defined by, so this is the meaning. If you have P of A, given, let me go by exactly what you have here. This one is rather P of B, given, A has occurred. So I will deal with that one before you come to the opposite. And if you remember when we were doing the dependent and independent, we did that. And I gave you the definition, mathematical definition. So you have PB given A is also always equal to, who remembers what I said? PB given A will be equal to it will be PA intersection B all over the probability of the event that comes after the given. So your denominator will always be the probability of the event that comes after the given. Please take note. We can prove this, but I won't bore you with the proof. Where again, obviously the P of A, because there's a fraction, should not be equal to 0. Very critical. So in the same way, if you have P of A given B, this will also be equal to P of what? A intersection B. All over P of what? Is it P of A or P of B? Hello, it will be P of
B.
B. Remember what comes after the given, so P of B. As simple as that. So if you know the probability of A intersection B, you go and find its probability of B, then you just substitute. As simple as that. So any question before we go and look at our worked examples? Any questions? We are all fine so far? All right. So quickly, let's go and look at what we have here. So in actual fact, for this one, it should have been, we take it from here. It is A intersection B. This one should be B intersection A. But we know that B intersection A is the same as A intersection B. Intersection is commutative, so we usually write, all the numerators will always be the intersection of the two events all over, the event that comes after the given with the probability attached. So let's go. Let's look at our first, worked example. So worked example 1, a die is thrown. A is the event. So 1, 2, 3, 5. So with the outcomes, Okay, 1, 2, 3, 5. And B is the event 1, 2, 4. Okay, so these are the outcomes of the event B. Find A intersection B, probability of A intersection B. Then B, find probability of A given B. Then C, probability of B given A. Is that clear? So now you know how to read it. Okay, so let's go. Okay, so with this, solution is what you write first. After that, what do we do? Question number, major question number 1. And please don't write Q1. Okay, Q2. The question number is 1. Just write 1. Okay, all right. So in this case, what do we have? We are going to extract. So I can write given. Okay, and write A to be equal to, okay, the outcomes 1, 2, 3, 5. Okay, and okay, B with the outcomes. So I have extracted my events, okay, mathematically. Okay, so this is what I have. Now we come to A. A, we are looking at what? Okay, P, A intersection B. Am I right? Okay, so you know by definition, once you know your event A and you know your event B, you can always find the intersection. And the intersection, okay, will be, so this one, it means you are going to get the number of A intersection B over the number of what? S. Am I right?
Yes, please.
Yes,
Okay,
please.
so now let's see how best we can find our A intersection B. As you mature, this step is not necessary. Just go and pick your A intersection B. So A intersection B, okay, what will be our number of successes?
Two.
Okay, which will be which value and which number? 1 and 2.
1 and 2.
Okay, so 2 over. So what will be your denominator?
6.
7.
It will be 7. How did you get the 7?
6.
How did you get the 6? Okay, so please, if you are forming your sample space, okay, you know it will be more or less everything combined here. Don't repeat, just like don't repeat any of the elements. So S will be equal to 1, 2, 3, 4, 5. Am I right? Indirectly, this is what we have. So be very, very careful. Don't count them. Just like 1, 2, 3, this will also be 1, 2, 3. Remember, these are not numbers, these are outcomes. So you cannot sum them straight away. If this was the number of A was 5, the number of B was maybe 3, and you are looking at the sample space number, then you add the two numbers. But here, outcomes, you don't add them in terms of the counts. You check if you have duplicates, you repeat them only once. Is that clear? Okay, so should I come again or my point is well made?
Your point is well made.
Okay, all right, so over 5. So this is what we have. So we've already drawn our conclusion. Then now what do we write? Okay, B, you leave a line. Okay. As for after extracting the information, you don't need to leave any line. If you are leaving a line, then it means you are moving from a sub question to another sub question. However, if you leave this line, you are just writing the first sub question. You are not moving from a sub, so don't leave any line. I've told you when to do so. So now B. Okay, what are we looking at? PA given B, and this will be equal to P of A intersection B, am I right?
Yes, please.
Over P of what? Of B. Is that clear?
Yes, please.
Okay, so this will be equal to, okay, we found our P of what? Of A intersection B. We need the P of what? Of B. How do you find P of B? What will be the probability of B? So it means P also, it will give us 2 over 5 over P of B will be the number of B outcomes in B, which is 3 over the number of outcomes in this, which will give us what? 5. So it will give us 3 on 5. Is that okay? Should I come again or my point is well made?
Yes, please. Please, your point is well made.
Okay, so that will give us, as for this was the introduction, okay, or introductory part of what? The probability. So we are going to get 3 on what? On 5, which in effect gives us 2 on 5, okay, times what? 5 on 3. So this cancel, and we are going to get, if this is your next page, you get that to be equal to what? Okay, 2 on 3. All correct? Hello, all correct?
Yes, please.
Okay, so we are moving on to the next one for C. Okay, so C. Okay, therefore, P of B given A, we know is equal to what? P of A intersection B all over P of what? A. Am I right? So if
Yes.
I write here, I avoid writing more than 1 equal to on the same line. I've exhausted my first equal to, or this even could have come down. That's how I usually deal with mine. So this would be equal to A intersection B. We found that, and that was the one that gave us 2 on 5. Is that not it? So divided by, okay, the probability of A. And probability of A will be the number of outcomes in A all over the number of outcomes in the sample space. So that will give us 4 on 5. Am I right?
Yes.
Okay, so in effect, we are going to get 2 on 5, okay, times 5 on 4. Okay, which gives us what? 2. Also, we can reduce, so 1 on 2. All correct. Hello, are we all fine?
Yes, please.
Okay, great. Okay, so in fact, this will be yours to try. Okay, so I'm going to move on to the next one. Okay, so let's look at this. Okay, question, which you will get your share as well. Okay, so with this one too, you've been given P of X, 1 over 4, P of Y, okay, 1 over 3, P of X union Y is equal to this. Find the value of. Okay, so let's see. All right. Okay, before you write, we always think before you write. So now we need to extract the given information. So solution, question number 3. Given, okay, or if not, you can choose not to write the given, but what you are going to extract must be there. So x equal to, sorry, P of X for, sorry, is equal to 1 over 4. Okay, P of Y is equal to 1 over 3. And okay, P of what? X union Y is equal to 1 over 2. Okay, so now let's see. You can see, okay, before you proceed, let's see what we are going to do. I just want us to think before you write. You know now that any conditional probability will involve the intersection of the two events. Is that not it? Because the numerator will always be the intersection of the two events, the probability of that. Okay, so it means with this, I know that I have to find the probability of X, okay, intersection Y. Meanwhile, this time around, unlike the first situation where I knew my outcomes, therefore I could go to my event X and find the probability of X, event Y, find the probability of Y, or look at the two events and look at the outcomes in common. And that will help me find the intersection. Here, I don't know the outcomes. I only know the probabilities of the events. So how then do I get what? The intersection. And please take note, anytime the question gives you the union, okay, the probability of the union, that is what you are going to use to, okay, get the probability of the intersection. And by this is what I mean. You know that the union formula, okay, the union formula, which is the addition formula, one of them involves what? The intersection. Do you remember? Okay, one of them, is it mutually exclusive or non-mutually exclusive? That will involve the intersection.
Non-mutually exclusive.
Non-mutually exclusive. Very good. So that is what we are going to quote. Okay, so before I even come to this, okay, I know that I will need my x, okay, intersection y. So here I'm going to write, okay, but, okay, my p of x union y, okay, is equal to what? P of x, okay, plus p of y minus p of x intersection y. Am I right?
Yes,
So if I state this relation, you can see that I know P of y, I know P of x, I know P of x union y, so I can easily find this, which I will need in the near future. You get it?
yes, please.
Okay, so at this point, I'll write this implies that my x union y, I'm told is 1 over 2. Okay, is equal to my P of x 1 over 4. Okay, plus my P of y 1 over 3. Then minus P of x intersection y, which is what I'm looking for. Okay, so in this case, what do I get? I'm going to get my P of x intersection y, okay, to be equal to, okay, 1 over 2 minus 1 over 4 minus, oh, sorry, I rather have to move this one here. So it will be, what minus 1 over, so it will give me 2 on, no, it's not 2. So it will rather give me, okay, so this will give us multiplied by 12. So give me the fraction. I can make this one, okay, 3, 4, 4, 3. So what will I get? Okay, I want us to do the subtraction straight away. Otherwise, the best way to go is add this, then later bring this. Okay, however, I'm taking this one here. So it's 1 over 4 plus 1 over 3, then minus 1 over 2. You let me write it. If you don't want to give me the value, then I will proceed. Then minus 1 over 2. Is that clear? So the next step, I write close to the margin. So give me the value straight away and let's go.
1 over 12.
Okay, 1 over 12. Okay, so this is what we have. So now I'm in a comfortable lead. A. Okay, I don't leave any line. No. I'm not moving from a sub question to another sub question. So I have P X, okay, given Y, you know, will be equal to P of X intersection Y all over P of what? Of Y. So this will be equal to P of X intersection Y. We have found that to be 1 over 12 divided by P of Y, and that was given in the question as 1 over 3. So it means this will be equal to 1 over 12, okay, times what? 3 on 1. So this goes here, and that will give us, if you continue, we are going to get that to be equal to 1 over 4. Am I right?
Yes.
Yes, please.
Okay, very good. Okay, so this will be 8 for what we have here. Okay, so let's see. Okay, let's squeeze the continuation there. So what do we have? The next one will be B. Okay, therefore P of what? X, sorry, Y, given X, we know will be equal to. What would that be equal to? Hello, the whole class, what would this be equal to?
P of x intersection y over P of x.
Okay, over P of X, very good. So the whole of this. So this will be equal to P of X intersection Y, that is now 1 over 12. Okay, then divided by P of what? X, and that was given as what? Okay, 1 over 4.
1 over 4.
Okay, so this gives us 1 over 12 times what? 4 over 1. Okay, so that will give us what? 1 over 3. We are done. Is that clear?
1 over 3.
Okay, so please, is my point well made?
Yes, sir.
Okay, we are all fine. Who is not fine? If you are not, please let me know. Kevin, are you fine?
Yes, sir.
Okay. All right. Gloria, are you fine?
Yes, please.
Great. Okay, so let me see. Regina, are you fine?
Yes, please.
Sally, are you fine?
Yes, please.
Nana, are you fine?
Yes, please.
Hey, okay. Then I think hey Cooks, are you fine? Okay, so we thank God. Okay, so I will leave these 2 questions for you. So the next one is this. So this one is going to be yours. Okay, you can see that this time around the probabilities, okay, given are in decimals. So it means your answers likely will also be in decimals. Don't change it to fraction. So if it's in decimal, then it means you are allowed to leave it in decimal. If it's in percentages, we are allowed to leave it in percentage. Otherwise, it should all be in terms of fractions. Is that clear?
Wait, Mr. Huffman.
Yes, please.
Can we change it to fraction before we
No.
talk?
Work with the decimals. Don't change it to. So that's why I said. Then it means we want your answers in terms of decimal.
Okay, thank you.
Okay, all right, you are welcome. Okay, so this will be maybe probably your class work. This one you are doing it and you are submitting it right now before the class ends.